Good morning, Year 9. Today is the 6th of April, 2020, and we're going to continue from yesterday's lesson. So it's part 2, now sets 1, and the learning intention for today is to use set notation. We're working from page 96 from our textbook, and we're going to today look at questions 3 to 5. Now, before we look at those questions, just want to quickly go through some of the questions from yesterday's PowerPoint regarding sets. So if I just open up a new share. So yes, as we saw from yesterday's lesson, so here we can say Rome is an element of A. For B, we can say 7 is an element of B. And here, Q is an element of set C, the letters of the alphabet. And here, 100 is an element of D. And then, as we said, if an element does not belong to a set, we write it in the fashion we saw yesterday. Then the questions I asked you to look at was to describe in words the sets below and state whether they are finite or infinite. Where possible, use set notation to write down one additional element that is a member of a set and one that isn't. So the first one, A, the set A, that's the colors of the rainbow. B was the triangular numbers, and it's an infinite set. C is girls' names beginning with the letter R. D, months of the year. Set E is the days of a week. Set F are the cube numbers, and there again are infinite. And G are your prime numbers. Again, a set which is infinite. So the three infinite sets here. So that's set B with triangular numbers, F cube numbers, and G the prime numbers. And remember, infinite means it goes on forever, whereas girls' names beginning with letter R, there's only so many. There's not an infinite set of girls' names beginning with R. So the number of elements of a set can be written as n in brackets S. So it said, if the question was list the members of the given sets below and state the number of elements within each set. So if I look at set A, this set A has the odd numbers less than 12. So we can say the number of elements in set A is 6. There are 6 elements, 1, 2, 3, 4, 5, 6. Here, set B, the even numbers, less than or equal to 14. So again, if you think of the even numbers, 2, 4, 6, 8, 10, 12, 14, remember it's less than, but includes 14 as well. So the number of elements in set B is 7. For C, the square numbers between 20 and 70 is going to be 4. That's the number of elements in set C. The D are your vowels. So there's 5 of them. Months with 30 days, 4. Prime numbers less than 39 but greater than 11 is 8. And the cube numbers is just 1. So sets can also, you can also write the number of elements of a set, and it's written in as n in brackets A, then equal the number of elements within that set. So moving back to our lesson today, sets part 2, so question 3 to 5. So if we look at question 3, it says describe the following sets by rule. The have is all connected. So first one, spring, summer, autumn, winter. B, the set is circle, ellipse, parabola, hyperbola or hyperbole. C is 1, 2, 4, 8, and 16. And D, you've got 3, 4, 5, 5, 12, 13, 7, 24, 25. So I'll give you a few seconds to think about that. Now remember again, the answers are in the back of the book. So if you was to check, so let's do the first one. So for the first one, the rule, have it connected, what the elements is the seasons of the year. So you've got spring, summer, autumn, winter. B, you've got circle, ellipse, parabola, hyperbole, and these are conic sections. C is the first 5 powers of 2. So remember, that's 1 squared, 2 squared, 3 squared. 2 to the power 1, 2 to the power 2, 2 to the power 3, and so forth. And then the last one is the Pythagorean triples, which we've not seen Pythagoras yet. Hopefully we'll have a look at it before the end of the year. But basically these 3 numbers here in a right angle triangle, if I add up these sides, 2 sides will equal to the length of this side square root. Moving on to question 4. Which of his elements, which of his statements are true? So is Everest an element of mountains over 2,000 meters high? 2,000 is not an element of leap years. So years with 366 days. So that's the year 2000. 2x plus 3y equals 5 is an element of equations with straight line graphs. D, -2 is an element of solutions of x to the power 3, subtract 2x squared, which equals to 0. So yeah, I'll give you a few seconds to think about it. You can pause the video if you like, and then once you've written your answers, you can click continue and check your answers now with me. So if we check the answers now, so for question 4, is true, yes, Mount Everest does belong to a set of mountains which are over 2,000 meters high. The year 2000 was false. It wasn't a leap year. C is true. So the 2x plus 3y equals 5 will always give you a linear graphs. And -2 is not a solution always for x cubed minus 2x squared equals 0. I wouldn't worry about too much of these things because it's not a topic we've seen yet. It's just be familiar with, do I know if this will be an element within this set? Okay, moving on to the final question. Which of these are examples of empty set? So you remember empty set means there's nothing in there that will go. So for example, set of kangaroos with 3 legs. Can you have a number, are there kangaroos with 3 legs? Well, obviously the answer is no. So that would be an example of an empty set. Part B, the set which has numeral 0 as its only member. C, the set of common factors of 11 and 13. And D, the real solutions of x squared equals -1. So again, if we look at the answers, it tells us that the only ones which are examples of empty set is A, so that's the one with kangaroo with 3 legs, and D, the set of real solutions, x squared is equal to -1. Okay? Now, because it's difficult for me to try and get a real understanding of how much you've understood the topic, because we all know you can easily just look at the answers at the back of the book, write them down, and that would make it look very positive for you. So once in a while, I will add in different questions from different textbooks which you don't have solutions to try and give you a better understanding of how much you've actually understood. So going back to the basic ideas with sets, So sets may be described. So example, could be the days of a week. Sets may be listed. For example, set B has the elements A, B, X, Y. And sets can be defined. So for example, set C, X to X is an even integer, X and Y. So again, these are things, we've already seen before. It's just be careful that you know that sets can be descriptive, they can be listed, and they can be defined. So there's a common rule that, why we've categorized them in these groups, in these sets. So the notations we use, so remember this, the Greek letter epsilon here means is an element or member of a set. With a line through it is not an element of. And as we've seen, the n with a in brackets is a number of elements in a set. So when a set contains an unlimited collection of elements, it is called an infinite set. So that's for your infinity. And when A equals B, the two sets A and B have exactly the same elements. So if A has elements 1, 2, 3, and B has elements 2, 1, 3. And remember, even though they're in different orders, in set theory, they're classed as being the same. They have the same elements. So we can say A is equal to B. So I'm going to let you do question 1 as homework. Please remember to do the questions in your book and then take a picture, upload it, and submit it onto Google Classroom, and I will mark it and feed back to you. So question 1 is, list the following sets. So for example, you've got the set of the months with 30 days. So you do your set, A equals, you do A equals curly brackets. Again, my curly brackets are not too good. And then write in here, shorthand if you like, the months of a year that only have 30, not 31 or 28. And then close the bracket. For B, you would again write set B, and then in there, list the set of whole numbers between 6 and 12. For C, again, you would write the elements, the set of names of the days of the week beginning with the letter S. D, letters which appear exactly once in the word mathematics. And E, numbers obtained by doubling 1, 2, 6, and 8. So for homework, can you do question 1 with all these sub-questions within there? Then question 2, it says describe these sets in words. So here for set A, you could say, you got these elements A, B, C, D, so you can say the letters of the alphabet. Set B, how would you describe these elements? What's the connection? Question C, again, how would you describe these elements? What's the connection? Why they're all being grouped together? And so forth. So yes, so we'll stop there. So 2 questions to do. Please try your best. If you're stuck or not sure, please message me or ask me to book a 10-minute Zoom session with you. I can go through these with you on a one-to-one basis. And, or if you, like I said, if you want to message me, then I'll write back to you as soon as I can. Anyway, enjoy the rest of your day, and I look forward to meeting up with you guys in the next lesson, which will be on 8th of April, and we're going to look at sets, part 3, looking at Venn diagrams.